2, 3.
Assalamualaikum warahmatullahi wabarakatuh. Today, I want to present about transfer function in subject Advanced Electrical Circuit. Okay, this is my team. The first picture is me, Muhammad Azhad. Second picture is Akif. Third, Ridwan. Fourth, Syahmi. And fifth, Farhan. Okay, introduction. The transfer function H omega of a circuit is the frequency dependent ratio of a phasor output Y omega, an element voltage of current to a phasor input X omega source voltage or current. Transfer function is divided by 4. First, voltage gain. Second, current gain. Third, transfer impedance. And fourth, transfer admittance.
Okay, this is the transfer function. Transfer function equation. So, first H omega equal to 100 J omega divide open bracket J omega plus 2 close bracket times open bracket J omega plus 10 close bracket. So next is the solution of the full solution of this equation, and then equal 200 J omega divide 2 times open bracket J omega divide 2 plus 1 close bracket times 10, and then times open bracket J omega divide 10 plus 1 close bracket, and the final answer is equal 10 J omega divide open bracket J omega divide by 2 plus 1 close bracket times open bracket J omega divide 10 plus 1 and close bracket.
This is magnitude in this equation. The magnitude plot represents the absolute value of a system response as a function of frequency. HTB equal 20 log 10 plus 20 log 10 1 j omega 1 minus 20 log 10 dash 1 plus j omega divide 2 dash minus 20 log 10 dash 1 plus j omega divide 10. H open bracket omega close bracket equal 10 j omega divide open bracket 1 plus j omega divide 2 close bracket times open bracket 1 plus j omega divide 10 close bracket equal 10 negative 1 open bracket 10 omega divide 0 close bracket minus 10 negative 1 open bracket omega divide 2 dash 2 divide 1 close bracket minus 10 negative 1 open bracket omega dash 10 divide 1 close bracket equal 10 negative 1 open bracket infinite close bracket minus 10 negative 1 open bracket omega divide 2 close bracket minus 10 negative 1 open bracket omega divide 10 close bracket equal 19 degree minus 10 negative 1 open bracket 10 divide 2 close bracket minus 10 negative 1 open bracket omega divide 10 close bracket. This is my way to get best plot based on count on graph. Thank you.
So next is phase plot. This is how we plot the phase at the graph. Next. Next is board plot. At the left side is our graph. At the right side is our solution. That will have four solution. The first one is constant, pole, simple, and simple pole. So the first one is constant is 20 log 10k equal 20, k equal to 10. Second is pole 20 dB per decibel alliance omega equal 10. Third is simple pole ODB per decibel alliance omega equal 10. J omega per 100 equal 1 negative 1. Fourth simple pole 20 dB per decibel equal 1000. H omega equal 10 multiply 1 plus j omega per 100 multiply 1 plus j omega per 1000. Next.
Discussion. A linear time invariant LTI system relation between its input and output can be expressed numerically by a transfer function. Typically, electrical engineering, signal processing, and control system use it. In the complex frequency domain, the transfer function is represented as a ratio of two polynomials which can be either the Laplace transform variables or the Fourier transform variables. And finally, conclusion. Understanding a system stability, frequency response, and transient response is made easier with the aid of system analysis. By disassembling complex systems into smaller, more manageable parts, it also makes it easier design compensators and controllers to achieve desired performance. An effective tool for the analysis and design of linear time invariant systems is the transfer function. By converting intricate differential equation in the time domain into more straightforward algebraic equations in the frequency domain. That's all from us. Thank you.